Hi guys, this is the crash course on Stormshield firewall. It will be focused on how to deploy a Stormshield firewall in most common cases. So we'll be taking a common architecture, and based on that we'll configure the firewall for both like network configuration, filtering, NATing rules, and general configuration. So it will be only focused on the Stormshield side, how the configuration is being done on Stormshield firewall side. I hope it will be informative to you. You may request for your demo virtual appliance at any time, so you can also be practicing as well during this crash course. So here I'm explaining the architecture that we have for this crash course. So I have a Stormshield firewall. It's actually a virtual machine in my lab, and it is connected in 4 different networks. I will explain. Let me just start the machine because it's just a new one and it will need to be set up. Normally, if you are on physical firewall, you can refer to my other tutorials where you have the configuration and you have everything to do when you connect to the physical firewall for the first time. For now, so we are on the virtual machine, and just to explain to you the architecture a little bit more. So let me take this, okay. So I have here on the firewall side, here I have one interface connected to my data center. So you can see here I have my data center on subnet 192.168.10.0/24. I have some application servers over here. Then you have here on one interface, I have the external interface connected to the internet router. And I have on another interface here a local LAN. In this LAN, I have some network, different network, 172.16.100.0/24 behind a router. And so we have here some routing inside. But on this side, we have the network, which is 192.168 over here. So this is the network 192.168.111.0/24. Now, my machine, I am connected to the firewall from my machine here to one interface to the firewall for the management purposes. So just to see how we are going to set this up on the firewall side. So the very first thing, let me just disable this one. The very first thing we need to do is to, since it's a virtual machine, so I need to set up from the CLI for the first time. So I need to choose the keyboard layout. 7 is the default for me. I have to pick my password carefully. Okay. Now it recognizes the first 2 interfaces. So it asks me what I want to have the configuration for. So I don't want to change the out interface. Later we will change, of course. I will keep it as it is. So no, it will remain DHCP. For the in interface, which is the one I am connected to from my laptop, I want to modify, of course. I will choose the IP to be 192.168.1.254. Yes. 24. And do I need to configure the virtual appliance for, yeah, if I want to manage the firewall from the out interface, I will say yes for now. All these things can be modified later. So as you can see, I have 4 interfaces. It gave me the option to modify the very first 2 interfaces. Normally, when you download your virtual appliance, you will have it with 2 interfaces. I have added extra 2 more later on from VMware, just to be able to simulate this lab. So don't worry about the details here. It depends on where you are installing the firewall. That's where it is different from one location to another. Now, I will go to connect to the firewall for the first time. Okay, and okay, I picked 1.254, I remember. So the first time you connect to the firewall, you have to put HTTPS IP address /admin. You will be into this page. So I will log in with username admin and the password that I have specified. So you can see here, it's a fresh installation. It's just a firewall for the first time I am connecting to. So this is the dashboard. You see the interfaces that we have. And I am on the monitoring tab. So if we want to modify things, we need to switch to configuration tab. And from here, we can do a lot of things. So just to make it fast, I will first need to modify a few things on the system configuration. First thing, I need to modify the time zone. So for me, I will pick something, okay? And then also on the firewall administration, I need to enable SSH. For now, I will just choose it to be enabled with password without using a key. So I will save. Okay, so now SSH is enabled, and management to the firewall here, access to firewall administration page is set any. That's what I have chosen in the wizard. I said no, allow it from the outside as well. By default, you can pick here only your internal networks or any access for the specific management IPs you want to allow to access the firewall administration page. So that's it for now. I'm switching now to the network side. So in the network, I would go to interfaces. And just to remind you, we have 4 interfaces. Interface number 1, which is by default named output. Of course, it can be modified. Now for the out interface, it's enabled. The name can be modified. I can say, for example, it's my WAN, and I can choose it connected to my internal network or external network. So for me, it's external, because if I go back to the diagram here, you can see that this is the first interface out, and it's connected to WAN. So that's why I have chosen it to be WAN. And for the IP, it can be dynamic, or you can set it manually. For me, I don't know what the router has given me, so I will just keep it as DHCP as for now. For end interface, I will change it to, because I'm connecting to as a management, so I'll make it as management interface. I will keep the IP that I have chosen during the wizard. For DMZ1, it's the interface which is connected to this network. Let me show you. So this interface is connected to this switch, which has a router here and has another LAN here, so to this network. So it is connected to 111, to network 192.168.111. So I will immediately change it to static IP, fixed IP, and I will put the IP 192.168.111.254/24. Update. So now I have set this. Okay, I will call it my internal LAN, for example. So it is an internal interface. I can choose, it's not an external. And finally, for the DMZ2, it's the one connected to the remaining one to my data center. So, and I will make the IP as fixed. And if you remember here, it's on subnet 192.168.10.0. So I will put 192.168.10.254/24 and update apply. So for now, I have configured all my interfaces with all the subnets. And if I'm going to the command line to check what I can see, let me just log in on the console. Okay. You will see that the IPs that I have configured are, the first one was DHCP, so it took 102. And this is the one for the management. This is the one for the LAN, and this one is for the data center. It just took a second to take the new name, so I have now LAN and data center. So going back here, I have it all set and I'm ready. So let me try to ping a few things. So 192.168.10.11. Yes, I can ping the data center. Let me see if I can ping. So the router. So the router is 111.100. I can't, because actually it has an access list. That's fine. It's a bad example. So going back here, let me just show you on the diagram. So I have them all connected. I have tested here. My laptop, of course, is connected. I'm getting an IP from this router, so it means also this interface is connected. And on this link, I have the local LAN already configured. Now, one challenge that I have to consider for now is that can these machines speak to each other? And this is something I need to be looking at. First of all, I need to make sure that I don't have any rule that is blocking the configuration. So in order to do this, I need to switch to the security policy to filter NAT. And I want to see what's the default policy. By default, there's a policy called block all. and we will spend a little bit of time on the filtering. So I will choose a new empty slot. I will take like filter 5, so it's an empty one. I will add a simple rule. Okay, and in this rule, I will choose the double click, of course, on the line, and then you get this dialog. So I will choose to pass. Okay, of course, it's a bad practice, but I'm just want to make sure that the network flow is going fine before applying any security policy. So I have chosen a rule. The status is on, the action is pass from any source to any destination port or protocol, and IPS is on by default on Stormshield. IPS is always on, so you don't need to go and explicitly enable it. So apply and save and activate the filter. So now you can see here the icon, this icon has been switched now, instead of block all, now on filter 5, because it is the one that is active. So you can choose only, you can work on only one, but you can have different configuration. It's really helpful, and you can roll back and exchange between different policies at any time. So it's not, we will be coming back to this later. So let me test something. Here I am on this machine, and this machine is the one, I will show you which one. So this is the machine, PC1. So this is on 172.16.100.10, and it's behind this router. So if I will try to, for example, ping from this machine, okay, let me just, no, sorry. So if I want to ping from this machine, okay, so I want to ping the firewall, it's on 111.254. Actually, there is no ping, as you can see. I cannot reach the firewall. And if I test on one, also it's 100, I guess, yes. So testing the router itself, 111.100 is possible to ping. So looking at the diagram here, so this PC1 can ping the router, it's 111.100, but it cannot ping the firewall. Of course, we can look at this issue in different ways. So one way to look at is to go to monitoring and to go to alarms and see if there is anything wrong. So I can see here, I have something saying IP address spoofing type 1. Source IPs will not show by default, just to respect the GDPR rules. So unless you want to come and request for obtain access to privilege for private data, so I will obtain, and immediately I can see the IPs, but it will be written in the logs that my user has obtained an access to the private data. So this IP is 172.16.100.10 is actually the PC1. So it is coming from a subnet that doesn't belong to the firewall. I don't have any interface on the firewall that actually has this IP or this subnet. That's why I'm getting IP address spoofing type 1. If I right click and want to understand what does it mean, IP address spoofing type 1, so I can go to help page. So normally you will see, let me just zoom in a little bit. So you will see that we have a packet process and invalid IP address of the interface. So it's a wrong IP coming to a wrong interface. It has different types. So I am on type 1. In type 1 saying that when a packet arriving on a protected interface, internal interface, which source IP address does not belong to any network inside. So as you can see in the firewall itself, all the interfaces are on 192.168 something, and there is nothing called 172.16. So it is a wrong one, and that's why it is being blocked. If I want also to look inside the firewall, so this is a little bit advanced. So the LAN interface is called EM0, as you can see here. So LAN interface, the one which this machine is connected to through the router, is EM0. So I can just perform the normal TCP dump. Okay, so I can choose the interface name as EM0. And I can pick a host, so 172.16.100.10, I remember, and see. Okay, so let me try to ping again. No, sorry. Ping the file. So I can see I can receive the echo request, but of course the firewall will not reply back, because this IP address is a spoofing IP, so the firewall doesn't know about. So we have seen this. Now, how to fix this? In order to fix this, we need to
go back to configuration and explain to the firewall that in the network, inside routing, that I have an internal network inside my internal network that is reachable through one gateway. So I will add a static root to declare this network. If I don't have the network already created, so I need to create it from scratch. So I will create a new object and I will choose the object as network. Remember, this is my destination network. So I will call it LAN internal, whatever. So the subnet mask is 172.168.100.0/24. Create. So I have this as destination network. And it's connected through which interface? So it's going through LAN. Now it has picked the address range. And then I need to define the gateway. So I don't have the gateway created. So the gateway is a host object. So I'll call it router 1. And the IP is 192.168.111.100. Okay, create. So I have declared this network through router 1 and save. If I go back, check, I can immediately ping now, because now this network is known by the firewall and it knows that it is coming through which interface. So from security point of view, it is allowing it. Why? Although that we have set the policy, as you can remember here, pass any, it was still blocked because IPS is enabled by default in Stormshield firewall. That's why it has recognized a wrong IP, but now the same IP has been added, and so it knows how to reach this IP and it understands it belongs to the internal network. That's why it was allowing it to go on. After that, now we have tested the connectivity from this PC to go all the way to the firewall. Now also, if we want to test the possibility to reach these internal servers, we can also do this. Let me go to the machine. I'm sorry I switched between them because I have multiple virtual machines running, so that's the reason. Just open the terminal. Okay, so let me just ping 192.168.10.11. This is the web server I have. So I'm able from the machine, the PC1, to reach to the server. If I want to test the web server, let me just check if I have access to internet. For now, I don't have access. So I will just connect to the server 192.168.10.11. The web server is up and running. I can test things and it's working. So, which means that I'm in good conditions now. I have a pass all policy on the firewall. So anything that is coming from outside, from inside, anywhere is allowed to be passing, except that the IPS is enabled. So that's how to distinguish between both. Especially the example when the IP spoofing was there. So it was an alarm set off by the IPS and blocked the traffic, where the other things I'm allowing, if they are not triggering anything bad on the firewall side, on the IPS side, sorry. So then they will match with the rules, which is for now is pass all. That's why it is passing. Now, what I need to do also is that to allow the access for this machine to go to the internet. So that's originally an important point. So we want to have access from this network to go all the way through the firewall and then go to the internet from here. And then also I need to allow a rule, allowing the traffic coming from the internet, reaching my mail server, and another one reaching my web server. So these two rules involve creating rules for both for NAT and for filtering, of course. So before we go there, we also need to understand what happened on the firewall side. So is the firewall capable of going to internet? As far as we remember that we did not set anything as a default gateway. The only route that we have set is a route to identify this network behind this router, behind this IP. So now the interface the out interface, which I have called as a WAN, was set to DHCP. So it automatically was receiving an IP from this router. And as a result, it also receives with the DHCP configuration the gateway, and by default the firewall will set it as the default gateway. However, this can be also modified. So let's see that. Let me sit here and switch to Firefox. Now, if I go back to configuration, network, I have routing here. So you see here I have an object called firewall_WAN router, and it has an IP 192.168.0.1. This has been identified by default. Now remember, all the IPs related to the firewall interfaces are named by these prefixes, like firewall_ normally refer to the an IP that has been obtained or belong to the interface of the firewall. Since it was obtained by DHCP, so it obtains also the gateway, and in this case, it has named it to router, and you see that it takes the IP by default. So here where we set the default gateway. If we have only a one gateway, that's fine. It's just a simple object we create here. But if we have multiples, it's a different configuration where you need to create a router object. And the router object, you can create multiple gateways and do between them load balancing, failover, whatever is required. Maybe that will be a subject for a different course. Now, going to the interfaces, just to remember, we have WAN. So in WAN, I have an IP that has been obtained automatically by DHCP, which is 192.168.0.102. I have the management, the one I am connecting through. I have the LAN, I have the data center. So these terms now, we will see objects that have been created automatically by the firewall using these names. So you will see something called firewall_WAN, which represents this IP, and firewall_management_LAN, firewall_data center represents the IPs of these firewall. You will see also objects called network_WAN, management, LAN, data center, which are representing the network that, or the subnet that these IPs belong to. So in order to create our rules, I will go to filter_NAT. And when we are working here on the filter_NAT, as we explained a little bit minutes ago, that we have multiple filtering file that we can use, and you can choose you can use only one at the end of the day, but you have multiple options where you can create different policies. It's really a nice tool. Now, here you have objects. So all the objects that are known on the firewall are identified in the firewall. Some of them are automatically added and predefined, and some you can create your own. Now, these are helpful when you are doing the configuration, is that you don't need every time to create an object that you need to go double click on the line here and go to this dialog and then choose your source, your destination, your port. You can do this for some configuration easily by just drag and drop. So let's create our first rule. So I will create a new simple rule. Okay, I will bring it on top because it's a top-down priority policy. So the first rule I want it to be for managing the firewall. Also, to make it a little bit clearer, so I'll go to create something called a separator. It means nothing, it's just an organizer. So in this organizer, I will just say this is to firewall management. Okay, and let me just add simple color to make it better looking. So in this rule, I will turn it on. I want to make it pass. So I have two options. Either I can just double click and choose from here pass, or I can just drag a pass from somewhere else over it so it can be easily taken. Source, I want for now, during this lab, I want to allow the management from specifically from my machine. So my machine is not identified. I can also choose from the network, for example. So the management network, the same subnet. So anyone connected to my interface can manage the firewall. So if I want to do this, I have, if you remember the interface name management that I have called, you will see an object called firewall management, which has the IP address of the firewall, and there is network management, which represents the subnet of this interface. So I can take it as a source. So I will choose the source, that anything coming from network management. Destination. Now, in destination, I need, of course, to add the IP address of the firewall. So it has to be coming to the management IP of the firewall. So here I'm saying from network management to this IP of the firewall on which port. Now, in the ports that I'm using to manage the firewall, I'm using HTTPS as one port. So as you can see, I can search and drag and drop easily. And also I have SSH. So I'll take SSH. Now, in order to make them both on the same line, I can just wait for this black underline to appear, and then I release, and then I can have both of them on the same rule. So no need to create multiple rules. You can add like 2, 3, 4, 5, and then you can create a group of them also. It's another good option. So in this rule, I'm saying that I'm allowing to manage the firewall, to access the firewall, either on SSH or on HTTPS on the web interface. And then I will create another rule, and I will create a separator in this operator, I will say I want to allow access for internal LAN to internet. And let me just make it look similar to that one. So my internal network, my internal LAN, is something that I can refer to by choosing an object called network. I have network management, WAN, LAN, the networks that I have. And also I have something called network internals. It's a group of all internal networks. But for now, I'm only concerned about my LAN network. So I will just drag LAN network as a source. And let me drag pass over this because I want to allow it to pass. Let me turn it on. And destination, for me, I want to refer to internet. So I'm concerned about allowing access to internet, nothing to internal, but to internet for now. So I'll choose destination internet. And for the ports that I want to allow, let me choose something called web. So web, it includes DNS, HTTP, and HTTPS. These are the 3 ports that are required to browse internet, browse websites, sorry. And maybe also I want to allow something else to open SMTP, something, any other service, so it can be added. And if I want to allow a specific filtering rules later on, maybe in different course, we'll speak about the security inspection if you want to allow it. So I have to separate them. So it's better if I remove this one and choose, for example, HTTP. And then inside security inspection, I can choose what I want to enable, like URL filtering for HTTP. I can choose the configuration profile. So it's for a different section we'll speak about. Anyway, let me, copy, paste also. So I have the same rule 3 times. And immediately you will see here below, you have something called checking the policy. It will always advise you about if you have anything that is wrong. Like it's telling me that rule number 3 and rule number 4, they are the same, will never be applied as they are covered by rule number 2 because they are duplicates. So this is good. You can avoid any duplicates. Also it checks if there is any rule which is error, wrong, written, anything. You will always get an advice down here. It will help you to have a good and working rules inside your policy. So in this case, I want to also choose DNS. Maybe it depends on the scenario. I would only be allowing DNS to my Active Directory or my DNS server, for example, as a source. Maybe I will be allowing only my network LAN to be accessing DNS to destination my DNS server. So it depends. I'm just giving you an idea of how different rules can be used. And also I want to choose, for example, HTTPS. So in HTTPS, I can also allow it here, so it will replace if you put it on top of the object. Now, why did I split them? Because as I said, maybe you want to apply URL filtering on HTTP, but on HTTPS, you can directly apply URL filtering. You need to do SSL decryption first. So it depends on the requirement. So for now, I am saying, access for my network LAN going to destination internet on HTTP, on DNS, on HTTPS is allowed. Now also, let me just paste again. And I want to say from my network LAN to access to data center. You can be very specific, and the better policy is to be more specific. So you can specify from network LAN to the IP of your web server, for example, and you specify HTTP and HTTPS, the IP of your DNS on DNS. So you have to be more specific. But here, just to see an example. So even the internal rules, although that we have, if I go back to the diagram, although that I have connected all the networks, so they are just being able to communicate, but this is not the good way. Of course, now it's time to enforce some rules and some filtering to say, this network can access, like this machine has access to a certain IP, for example, but on a specific port, and then another access to another IP on a different port, and access to internet also. And then you specify schedule, time, whatever you need to specify. So it's not like we leave it open, but this is an excellent way to do kind of segmentation. So they can communicate, but you are doing a proper segmentation in between. So nothing can access without being inspected by IPS and being applied under the filtering rules as well. So I have specified some generic rules and between network LAN and data center. For me, I don't have any reason for my data center to access the network LAN, so I don't need to create the other way around unless it was required. Now, it's a stateful, so you don't need to create a rule for the reply. The reply is handled by the connection itself. Then let me create another separator here. Bring it down. And I want to say that I want access, for example, access my web server from internet. Okay, so this is a simple filtering rule I am adding to allow access to my web server from internet. Now, let me create this rule. So simple rule, pass. And the source will be coming from internet. Okay, so I will choose the internet object. You can, of course, use it from anywhere. You can drag it to anywhere inside the filtering policy. And destination, it will be, for now, this is a private IP. My web server is a private IP. I did not configure it yet, by the way, but we will create it shortly. So, but I want to say that I'm allowing access from internet. Normally, the connections will be coming to my firewall for my firewall interface, which is connected to the outside. In my case, for example, it's the firewall LAN 1. Sorry, so I can choose firewall 1. It's the one that I have here, and I'm only allowing it an HTTP port. Turn it on. So I'm saying, okay, access from internet to my firewall 1 to HTTP. Of course, this is ridiculous, because I'm just saying that from internet can access my firewall IP on port HTTP, which I don't have anything on port HTTP on my firewall. But later on in the NAT rule, we will see how we will create a rule to redirect any request that comes to my firewall 1 to go to the private IP of my web server. So let's add a separator here. And let me make this rule as I want to allow ICMP between all networks. So I will just say allow ICMP. Okay. And because ICMP is a different protocol, so I will just define it as any, and I will choose here under protocol in this empty space. You can directly jump into the port protocol. So now I can choose a port if I am specifying a TCP, UDP, whatever service. But if I'm speaking about different protocols, so I need to change this to go to IP protocol. Of course, there are rules for application protocols, rules for Ethernet protocols. I'm concerned about ICMP, which is an IP protocol. You can go inside IP and see the ICMP protocol. And then I don't want to open all ICMP protocol because it's risky. I'm only concerned about echo request, so I will just only allow the echo request and say okay. So this is involving that, saying that from any source to any destination on ICMP echo request is allowed to be passing. Now I have a warning here saying that the rule has a dynamic address of firewall as destination, but no interface is specified. It's rule number 6. Here I'm saying that it is warning me that I have specified an IP, but it did not specify an interface. It is recommended to specify an interface. However, this will also work, okay? But it's just a warning. There's a difference between warning and error. It's much better to specify, for example, in your source, and to go into advanced configuration and choose source port, in general, to choose the source interface here, incoming interface, say any connection that is coming from one interface. So you can be very specific. So you say anything coming from internet, but to be more specific through one interface, because leaving it generic means any IP that would be coming from outside. And imagine that you have turned off the IPS here, so it's not matching the IP spoofing or IPS alarms are enabled. So this IP can be coming from any interface, and then as a result, you are allowing access. So it is much better, more recommended to specify, or in other words, it's more secure to specify the interface. Now, behind this simple view, there is the advanced view, and I believe that you have seen a little bit of examples. So if you double click anywhere, you can see in every place there are more details. So you can specify the geolocation, you can specify the host reputation. So in the internal network, you have a host reputation that can be built, and you can specify a threshold, a specific threshold based on the security scoring of each host. You can allow access or not. And then advanced configuration, you can specify the outgoing interface, and then a very nice feature, which is doing a NAT on destination. So instead of creating a NAT rule, you can directly, for certain scenarios, create a NAT rule here. So let's, you will see a lot of details in every section of these filter rule components. So you can, for example, in general action, you can choose to specify the action and then the log level, and then you can apply scheduling, and then you can do policy-based routing by adding a gateway here. So anything matching with this rule will be routed through the gateway that you choose. The same in the quality of service, you have a lot of things to be applied. The same also in the advanced, you have a lot of things that can be applied as well. So this is just an example. Now I have a warning here saying that the active policy is not up to date, because this is an active policy number 5, and I have modified it, but it's not up to date. So the one that is running is different than the one I'm working on here. So this is just a notification. I will just hit apply, and it will ask me, okay, this rule, this filter policy has been updated, but it's not applied yet. So you can choose to apply later, or you can choose to apply immediately. So I will just apply immediately. Now, this is all for the filtering rules. I will go to NAT rules and see what I need to do. I have 2 things to do. In fact, one is with regards to my internal network. When they are going to the internet, this LAN, when it's going to internet, it has to be NATed before it goes to the internet. And the same thing, anything that is coming from the internet towards a web server to the interface of the firewall on HTTP, it has to be redirected to this web server. So I need to create 2 NAT rules, one for my local network to go to the internet, one for anything coming from the internet on web to be transferred to the internal web server. So in order to create these 2 rules, so when I'm allowing my internal network to go to internet, it means I need to do not only NAT, but also PAT, port address translation. So I choose the dynamic rule, which by default adds the PAT range to be also translated. So this is the rule, as simple as that. The only difference between this rule and by a simple rule is that it by default added the source port. It chooses this range, ephemeral firewall range. So it will do a port address translation for the source port. Now, this is something, it's not mandatory to be done from the wizard. You can just choose a simple rule and add it later. It's fine, it will be the same result. Now, in NATing, it's very simple. You have to understand that you are telling the firewall, in the left side, I have the traffic before translation. In the right side, I have the traffic after translation. So what I want to do with it. So any packet that matches on this side, what I need it to be done or modified on this side. So you only modify the things that you want to change. If you don't modify anything, it will leave it as it is. So first example I have for my network LAN. So I will choose the LAN. So I have network LAN as a source. When it's going to internet, so I need to choose internet as destination. Or let me turn it on so the color will stop being gray. So from my source network LAN going to internet on any port, I don't want to specify any port, what I want to do with this traffic. So any packet coming from my internal network going to a destination belongs to the internet. Internet means any external IP. And on any port, what I want to do with it, the only thing I need to modify is actually to change the IP to go, instead of my private IP, to go with my public IP. Of course, in my scenario, it's not really a real public IP, but it's just for example. So firewall 1, let's assume this is my public IP. It will be on my external IP. So this is what will be done. By default, the rule has specified to replace the source port. So if you did not choose the dynamic rule and you choose a simple rule, you can also manually add the range over here. So this rule simply will allow me to do a full NAT. Now let me just add a separator and add another separator, bring it down. Okay. Now I will create another rule, simple rule in this case, where I want to publish my web server. So my web server, currently I don't have the IP created as an object. So I need to create an object. So I will click here, create an object, and I will say web server. The IP of the web server is 192.168.10.11 and create. So I have now an object called web server. If I look here, it's here, web server. Now, the traffic, how it will look like when it's coming to me from the internet. It will be coming from internet as a source. The destination, it will come to my out interface. So it will be going, I'm dragging things from different places because it's easier to me. So I'm choosing the firewall 1. So this is how the rule will be looking like. So source coming from internet, from any IP, external IP, coming on my firewall out IP or firewall 1 IP. And I need to specify in this case the port, because now I'm only doing a port forwarding. So I will choose HTTP. So you can see here from internet to my IP, the firewall IP on HTTP port, what I want to do with it. I only need to change, in this case, the destination IP. So after translation, I will keep everything the same except the destination IP. Instead of it was going to my public IP, I wanted to go to my private IP of the web server. So I'll just drag the web server here on destination after translation. So this rule is enough to do the translation for any connection coming from outside. Now, again, I have a warning here. The rule has a dynamic address because it keeps repeating this warning again. Maybe I forgot to mention this earlier, because again, the firewall one I have is actually has been obtained by a DHCP. So it also notifies me that this IP is dynamic. So next time it might receive a different IP. So it's better if I'm referring to a dynamic IP on DHCP. So it's better also when I'm specifying the source, not only to say the IP or anything, I need to specify also the interface. So I'll choose my one interface to be more specific and to cover all the cases. So this is it. I will just say apply and let me see. Now network LAN is 192.168.111.0. My host over here is actually behind the router. This one, if we want to see the IP address of this one, it's a bit slow, sorry. Let me just in the meanwhile just show you that if I try to access the internet, I can't access internet actually in this case. Although that I have created the NAT rule, but I can't access internet. And the reason behind that, this IP is from a different subnet and it is behind the router. So it is routed through another subnet and coming to the firewall from a different subnet. So that's why, and just let's go to the diagram here and highlight it a little bit more. So this IP here is 172.16. When I created the rule first in the filtering rules to allow access from my network LAN, this is what is network LAN about. It's 192.168.111.0. This IP is coming from a different subnet. So, which means that it will not match with this rule. That's why I don't have a rule allowing it to access internet. Plus, I don't have also a NAT rule to translate this subnet to when it's going to the internet. So it is mandatory to include this in order to allow it to access internet. So going back here, I don't know why I'm not getting. Oh, sorry. I have to stop this one. Sorry, it's a live recording. That's why I'm not getting the details as I want. So here you can see it's a 172.16.100.10. So it's not within the subnet. So let me go back to the firewall and include this in my configuration. So in my configuration, I want to add the 172. Currently, I have a subnet called LAN internal, the one I had created. So I can just simply say, allow this, okay, in my NAT rule. So beside my network LAN, I will add also LAN internal. So this subnet also, it will be translated when it's going to the internet. And the same thing also in the filtering. When I have allowed the access here for my network LAN, okay, on HTTP, on DNS, on HTTPS, also the same has to be added for all of them. Or I can combine them in one rule. This is just an example to show you how we can drag and drop things. So I will just apply and save. Okay, done. So filter and NAT both have included the LAN internal. Going back here, check. I don't have access, most probably because I didn't have DNS. It was a bad example to. I should have checked the DNS earlier. Okay, so in IP4, not automatic, let me put it to manual. I will choose the public Google DNS, apply, save. Yeah, it's something funny that I need to disable the interface so to take the new settings. I'm not really familiar with, but this is a machine that is very small and tiny. That's why I have picked the OpenSUSE operating system. So you can see I got the access to internet. Now, just to confirm that I'm not cheating. Okay, so let me just remove it from here and remove it from the filtering over here. Okay, save. Now I'm supposed not to access internet. Let me just again do Google, whatever. So again, I don't have access. It will not work. So that's an example, is that I am able to go to internet, I'm able to publish my web server, I'm able to do all of these things. I hope it's clear, and you can also check further in the alarms, in the Google traffic, in the logs, and here you can see the audit logs. Here you can see, you can build some reports, maybe in a different course you can see, and also you can go to monitoring and monitor things. So you will see inside the hosts, for example, all the hosts that has been identified internally. So currently I have 3 hosts involved. So I have one which is my machine, actually. The one is for the management. And I don't have access, restricted access, so I need to obtain access. This is to be compliant with the GDPR rules. So obtain access to privilege, obtain. Now I can view details inside any host. So when I click on this is my laptop, and it sees that the connection that has been opened by my machine, and they are all SSL to the management of the firewall. This is the internal host, okay, the one on the different subnet, and this is my router in between as well. So you can see these details from the monitoring. As long as you open any connection, immediately you'll see the open connection for each host. Once the vulnerability, for example, enabled, you will start to see vulnerabilities application, and once the server is enabled and updated, I don't have it ready on this firewall. So one more challenge that we are facing is the need to change something in the architecture, and we need to modify things. As you can see in my scenario here, my network is actually on this subnet. So if I choose, or like the administrator has decided that no, I want it to be a flat network, but also isolated. So in that case, I will need to do something that is very strange sometimes, is that if I will move to the next slides, you can see here a change. So we have, in this case, this IP has become .10, 192.168.10, and also this whole inside LAN has turned into 192.168.10.100, 10.10, whatever, which is actually is the same as the network in my data center. So I have the same subnet, it's a small network, and the admin, for some reason, or there are some applications that don't work on different subnets, so it will only work with their, I don't know whatever reason that could be. So I need to adapt to this configuration. Now, in order to adapt to this configuration, it means that I need to modify on the firewall a few things, including that I don't forget that for reaching this network, I had to create a static route to this gateway over here, which means that I need to take this into consideration. And then also in my filter and NAT rules to access the publishing the services, there's nothing will be changed because this IP is the same. But in this case, I need to also, to allow my internal network key to go to internet, I need to consider this as well in my rules. So let me just check that on the firewall side, and let me just stop this. Okay. Now, in my, I'll go to configuration, sorry. So inside configuration, I will go inside objects, okay, inside network objects. I have one host that is representing this internal host and the internal IP. So I can find it from here directly, or I can just search for it. It was 192.168.111.100. So it was called router 1. Now I need to modify this one to match the new configuration. So it's 192.168.10.100 and apply and save. If I go inside network routing, you see that I still have the same subnet on the same interface, on the same range, and the router IP has actually this time has changed. So once you modify something in the objects, you will see that it takes place wherever it is being used, and that's the beauty of using objects. Now, furthermore, let me just search again for the object that I have. This router that I have, okay, you can always get to know where it is used. So whenever you are modifying something, there's always an option here that can say check usage. So when I click, it will tell me this one is being used inside routing. So this is very helpful to know before modifying anything in which section of the configuration it's being used. Now, after that, I need to go to network interfaces. Now, currently, I don't have this subnet. So I don't have like LAN on this subnet and that center on this subnet. I have them both on one subnet. And I need them to communicate. I need them, again, to be able to be NATed. I need them to everything to be working the same. So in this case, we use something called creating a bridge. So I will create a bridge, add a bridge. So this bridge, the members of this bridge are the LAN and the data center. Both, they are member of this bridge, okay? And I will just hit apply. I need to specify something. So it's saying that the interface are derived object is being used in the configuration. The interface cannot be moved to a bridge. So it is telling me that you have a problem. You are using something, and this thing that you are using is actually part of the configuration. So if I modify it here, it is actually affecting what I'm doing. You want to do this to know where did this come from. So I can just simply click on LAN, check usage. It tells me that LAN is part of all of this kind of configuration. That center, again, also, it will tell me where it is being used in the configuration. So it is used inside the filter NAT. It is part of a group called firewall all, network all. It's part of vulnerability cell host. These, we did not configure them, so we are concerned about the filtering rules that we have been working on. So that's the only thing that we have modified. That's why before getting rid of these two interfaces, LAN and that center, before we modify them, the first thing we need to do is to go back, and in the filter NAT, sorry, here I need to discard the configuration. And because I'm doing this live, so it's fine. I'm sorry that I may do mistake, then I need to go and do it later. So you can see here that all these rules, like network LAN is there, and they have network data center. So these components are actually relying on the interface that center and interface LAN. The same thing in the NAT rule. I have here network LAN, and I have here also the, no, here I don't have anything related to filter, no, I don't have any problem here. No interface is being used. But in this rule, I'm using the object network LAN, so this will change. So let me turn this off for now. In the filtering, let me turn this off and see if turning them off is enough, okay? And also this one, includes, no, sorry, it has only firewall 1, so it has nothing to do. ICMP ping is for all. Firewall management is separate. So now I have disabled the rules related to these two interfaces. Going back to interfaces, let me try this time. Add, bridge. Okay, so I will put LAN, that center. Okay, I still have this error. And apply. It will tell me you still have the error because they are still exist in the configuration. So disabling it is not enough. I need to remove them. So don't save again. And I need to remove them. Oops, sorry. I can hit shift and choose multiple rules. It's easier. And in the NAT, I will delete. Okay. And apply and save. Again, interfaces. So I can choose these two interfaces, add bridge. Okay, now I don't have error because I don't have anything in the configuration that represent them. So I will just say save. Dealing with interfaces, it takes time to process and modify the configuration. Now this bridge, okay, we should define an IP address because now this interface and this interface has no IP addresses at all. They belong to a bridge. So IP is actually defined at the bridge level. So I will choose a fixed IP, and I will refer to the IP 192.168.10.254/24 update. So this is the IP will be the gateway for both of them, and the IP that both interfaces will be communicating through. Now going back to fix my filtering rules. So in the filtering rules, let me just add a simple rule here and say I will bring the objects and I will say internal. I only want to allow my LAN internal for now for the test to go to internet. So let me just bring pass on, doing things fast because we have done it before. And destination is going to the internet. So I'm saying from my LAN, from source LAN internal, the subnet that is behind the router, going to internet. I want to provide it access over web services in general. Let me just make it like this to make it fast. So it includes this one, HTTP, HTTPS, and DNS. Okay, and in the NAT here, I will create a new dynamic rule, bring it up, and I will say the source is my LAN, because I'm only concerned about the LAN for now, just to test and on to see the difference. When it's going to internet on any port, I want it to go through my firewall 1 source IP. So you can see here from LAN internal, going to internet on any port, after translation, only the source IP will change to the public IP that I have. Apply and save. Go to the machine itself and test. Going to internet. Yes, it is working because now we have adapted. Now, if you look at the configuration here, you will see that we have created a bridge in between, and this bridge is very unique because once I create a bridge, it doesn't mean that I lose connectivity or I lose features. Still, I can do full routing, full load balancing, full inspection, everything. So the deployment mode on Stormshield firewalls has nothing to do with the features. So I just create the bridge in between those two networks so they can communicate in both directions. And at the same time, while they are communicating, they are filtered by the IPS and the filtering rules and the firewall rules and everything. I can do NATing, I can do filtering, I can do whatever I want, static routes, if they are still working. So it doesn't turn into just a monitoring, but it has nothing to do. All the features will remain working. So that's all for our example in this crash course. I wanted it to be very fast, nothing much of preparation, I would say. Just facing the challenge, modify it, working on it, just to give you the experience when I'm dealing with the Stormshield firewall.